This video is about central angles and arc measures. Just a footnote before we start. When we talk about arc measures, we can measure the arc of a circle, meaning a portion of the circumference, by either degrees or by its length. So make sure you make that distinction. The first half, we're going to talk about how to measure it by degrees as it relates to the central angle. In the second half of this video, we're going to talk about how to measure it by length in terms of distance. Okay, so let's start. I should note that this is 10.2. And definition, a central angle is an angle with its vertex at the center. In this example on our left, it's point B. That's the center of the angle. And the central angle is formed with a vertex, with its vertex at the center and its two sides and as the radii. The sum of all the central angles in a circle is 360. So this is a fancy way of saying I start my angle here, I spin around a whole full circle. That's an ugly small circle, but you got the idea. I start with AB, I end with AB. This golden part is 360. But this green part, angle ABC, that is 84 degrees. So there's a huge difference there. Okay, so this example is angle ABC is my central angle, and its measurement is 84 degrees. The degree of the arc formed by the endpoints of a central angle is equal to the degree of the central angle. So this is equal, meaning when I look at 84 degrees in the center here, okay, of angle ABC, because it starts with A, it ends with C, it determines that this arc measure is also the same degree measure as 84. So over here I have 84 degrees as well. It's just the same as the central angle. And the arc measure of ADC, the other way around. So this part, A and then D, order really matters. The golden part of that arc is 360 degrees minus 84 degrees, which should give me 276 degrees. Okay, now let's look at some examples here. In the first example, I'm given 21 degrees, and I also see that this is 21 degrees because they're vertical angles. And also, if I use a different color notice that this is 180 degrees. JNL is a diameter. That's 180 degrees. Therefore, this part is 180 minus 21, which gives me 159 degrees. And the vertical angle on this side, JKL, is, I'm sorry, is that right? Right, so this part, the red part is 159. 159. The blue angle is 180 degrees. Okay, so with that, I can fill in the blanks here. The arc measure of JK is given at 21 degrees. The angle JNM is 159 degrees, and KL correspondingly 159. JKM is 180 between K and M, and then add 21 to it, I have 201 degrees. and MKL, arc measure MKL. MK is 180 plus wait, what is it? Oh, I'm MK from M to K is 180 degrees. Then from K to L should be, this part is 159 degrees. So 159, you add that, and you should have 339 degrees. Okay? So that's the calculation here. Now let's look at problem number 3. It's given here, FE is 34 degrees. So this is 34 degrees. This is 90 degrees over here, and in this one of the central angles. So this part is 90 degrees. So now I can do all sorts of things. Then I know this is 90 degrees. This is 90 degrees. This is 90 degrees. This GF here, use a different color. GF must be 90 degrees minus 34, so that should give me 56 degrees. And now I can fill in the blanks here. CD is obviously 90 degrees, and FD is 90 plus 34, so 124. Arc measure of DCF. DC is 90 degrees. F is, I have to go DCG, that's 180 plus 56. So I should have 236 degrees. And the last one is 304 degrees. Okay, I suggest that you press the pause button on your YouTube, on your video, and finish number 2 and number 4, and I will write the answers up here, and then you can come back in 2 minutes after you finish this problem to verify your answers. Okay, I have put the answer key up on top, so make sure you verify it. I hope you got it right. If you make a mistake, make sure you understand how you made that mistake. All right. The next section is actually, believe it or not, it's relatively easier, but it does have a little bit of algebra in it, so you need to know what makes it work. How do you set up the equations? I'm going to go straight into number 7. So in number 7, I have the information given is this arc and this arc, right? And this arc corresponds to this central angle, and this arc is corresponding to AED as the central angle. Now, these two central angles are vertical angles, therefore, these two angles are congruent to each other. That's 2x, that should be 34. X is 17. Once you have 17, the rest is easy. It's just a matter of basic pre-algebraic skills. Plug it in and solve for each angle measure or arc measure. Okay? I think that is it. The others are fairly easy. So again, press pause, finish it. I will put the answer key online here so that you can verify them. See you later, guys. Here you go. I gave you the answer for 5, 6. I'm going to jump into the last one in this section, number 9, because probably this is the most challenging of them all. So let's look at this. I've got, what do I know? I know if this is 90 degrees, this arc length must measure 90 degrees. And I think I have all the information. All I need to do is to add them together. oops, that's a degree, plus 90. I'm going counterclockwise. And I add them all together, they should equal 360. Okay, I often do a trick here because this is my trick. I have 21x, I have 8x, that's 29. 29 plus 10x, that's 39x. So, oops. So before I move on to the next step, I have 39x right there, right? And then I'm adding the numbers together, the constants together. The constants are negative 12, there's nothing here, plus 90, so that gives me 102. Oh, no, I'm sorry, it's negative 12, so 78. 78 plus 9 is 87. So, whoops, check my math there. Is that right? 1287 equals 360. And then if I subtract 87 on both sides, I should have 273. Yep, that's right. X comes out as 7. If X is 7, again, I'm going to plug in the corresponding angles. That's 146. Please check my mental math. I really should be doing it on a calculator, or at least to write it out. But I'm being lazy now. Okay, that's the first part of this. I'll come back with the second part of the video, but for now you should all finish this guided notes up till this point. Thank you guys. Bye. 7 and 9 is oh, let me see, I'm sorry, let me bring that down. For some reason I did 9, but I didn't do 8. So 8 is 9, 68, 112, and 248. Okay, that's it for this first part. I'll come back with a separate video for arc length, and that's how we measure the arc by its length rather than by the angle measures. Talk to you later, guys. Okay, now it's time for us to see how do we calculate arc length. Think about it this way. We just learned how to calculate the arc measure in terms of degrees. And if we know that the certain parts of the arc is equal to the central angle measure, and the central angle can be a portion of 360, right? So, in other words, if I have the arc measure of x degrees, and as a percentage of the total circle of 360 degrees. So that gives me a proportion. If I just use that multiplied by c, and c is circumference, and circumference is calculated as 2 pi r, or 2r is 2r is diagonal times pi. I just noticed that my key has a mistake in there. So that's what gives me the length of that arc I'm trying to measure. In other words, find the proportion of the central angle the arc faces as a percentage of 360 degrees. Then multiply that with circumference, and then you got that portion of the arc length. So some examples here. EB is 15 centimeters. Find the arc length of CD. CD is right here. So in order to find CD, what do I have? EB is 15, so this is R is 15. Okay, I'll go back to red. R is 15. So I can calculate the circumference equals 2 pi r, which is 2 times 15 times pi, and that's 30 pi. And now I have 68 degrees here, which means over here, angle measure of CED, which is the central angle that faces arc of CD. And that should be 180 minus 68 degrees, right? And that gives me 112 degrees. So now the proportion is, so the length of CD is the proportion of 112 over 360 multiplied by 30 pi. And that should give me 3360 pi over 360. It's approximately 29.32 centimeters. Okay, that's how we calculate that. That's how we calculate arc length. Let's look at number 12. If VS is 12, so VS is the diameter. Diameter it equals 12 meters. Find the length of UT. UT is right here. So in order to find UT, I need to find this angle here, the central angle. And let's see, what do I know? I know that I cannot probably find quite the central angle, but I can find this angle, VWU, right here. So, oops, sorry. Angle measure of VWU equals 180 minus 127. That should give me 53 degrees, right? And then if I have 53 there, and I know this part is 90 degrees, so 90 minus 53 would give me the angle measure of UWT, which is the same as the arc measure of UT, which is what we want. And that's 90 degrees minus 53 degrees. So I should have 37 degrees. So that's what I need, and this is what I need. And now I put it together in my formula. Let me use I think I used blue in this example. That should be, the proportion there is the central angle, 37 degrees, over 360 degrees. That gives me the percentage. And then circumference is diameter, or 2r, which is 12 times pi. And if you calculate that, that should be 444 pi over 360. And it's approximately 3.87 meters. Okay, the last example I'll demonstrate before I let you do the practices is number 14. So FG, which is my R, is 27. So that's good. So I've got my circumference that I can calculate. 2 pi r is 2 times 27 times pi. That's 54 pi. Now I'm asked to find the length of FED. So it's this large arc here. And in this large arc, I already know this is 90 degrees. That's good. So I need to know this, right? And therefore, the central angle of DCE should be 360 degrees minus 80 minus 47 minus 90 degrees. That's what I would get. So that is, I think it's, check my math, I think it's 143 degrees. Now, in order to find the central angle of DCF, which is the same as the arc measure of FED. I forgot the little thing there. So let me make this a little better. A little better looking. There we go. So I should have 143 plus 90 degrees. So 143 plus 90 degrees, I should have 233. That should be the correct answer. So now I put it together. The length is the central angle I'm looking for, where the arc measure is 233 degrees over 360. Use that proportion multiplied by my circumference, which is 54 pi. And I should have eventually 109.8 yard for that length. Okay, so again, the approach is to find the central angle that corresponds to the arc length. Once you have the central angle, divide that by 360 so that you know the proportion, multiply by the circumference, then you're all set. All right, guys, I'll see you in school. Bye.